Yeah, good evening, children. Online children, my screen is visible?
Yes, ma'am.
All right. So today's topic is algebraic identities. So it is a subtopic in the chapter polynomials. Okay, so in this chapter polynomials, we have something called the remainder theorem, factor theorem, and the last part of this chapter is algebraic identities. So we're going to have a look at some important algebraic identities and their derivation in today's class. All right? Yeah. So the first one, a plus b the whole square is equal to a square plus 2ab plus b square. Very familiar, right? Okay. So how do we derive this identity? Now, what is a plus b the whole square? A plus b the whole square is nothing but a plus b into a plus b, right? What is 5 squared? 5 into 5. Similarly, a plus b the whole square is equal to a plus b into a plus b. So now how do you find this product? This is a binomial, two terms. It's a binomial. This also has two terms. Okay, so binomial. So this is the product of two binomials. It's a product of two binomials. We'll have to multiply these two binomials, these two expressions which have two terms. All right. Okay, so how do we multiply? The first term multiplied with the second bracket, the second term multiplied with the second bracket. Okay, so that's how we multiply. The first term a into the second bracket a plus b, the second term here, the second term in the first bracket plus b into a plus b. This is how we multiply. Next step, a into a square. A into a square. A into b, so there's plus here, so plus ab. Plus b into a plus ab. Plus b into plus b squared. All right, now ab plus ab. It's 1ab plus 1ab, so 2ab. So a plus b the whole square is equal to a square plus 2ab plus b squared. All right. So a plus b the whole square is equal to a squared plus 2ab plus b squared. Okay. Next, a minus b the whole square. So we are familiar with this identity. A minus b the whole square is a square minus 2ab plus b square. So how is it derived? A minus b the whole square is nothing but a minus b into a minus b. Multiply first term a into the second bracket a minus b, second term minus b into the second bracket a minus b. A into a squared, a into minus b, minus ab, minus b into a, minus ab, minus b into minus b, minus into minus plus b into b squared. Right? So again, we have minus 1ab, minus 1ab, minus 1 is minus 2. So minus 2ab. So a minus b the whole square is equal to a squared minus 2ab plus b squared. All right. Next one. Again, this also is familiar to you. You've seen all these three in standard 8. X plus a into x plus b. X plus a into x plus b is equal to x squared plus a plus b of x plus ab. So this is the identity. How do we derive this? Okay. So x plus a into x plus b, x plus a into x plus b is equal to the first term x multiplied with the second bracket x plus b plus a, the second term plus a multiplied with the second bracket x plus b. First term into second bracket, second term into second bracket. All right. So now x into x, x squared, x into plus b bx, plus a into x plus ax, plus a into plus b plus ab. Right? Yeah. Now, no like terms. Like here we had minus ab, like terms. So minus 2ab. Earlier one also we had plus ab, so plus 2ab. But here we have no like terms. There are 4 terms, 1, 2, 3, 4 terms, but no like terms. Okay, so what we're going to do is these 2 terms have x in common. So we're going to take out x common. These 2 terms have x in common. So write this term as it is x squared. Here x is common, so x common. So you'll get b plus a in the bracket. Okay, b plus a in the bracket and plus ab. So this can also be written as x squared plus a plus b of x plus ab. Just putting this x behind and writing b plus a as a plus b. So this is how we have this identity. When you multiply x plus a and x plus b, this is the result. This is the result. And that's what we call an identity. When you multiply this binomial with this binomial, this is a binomial, x plus a, 2 terms, binomial, x plus b, 2 terms, binomial. The product of these 2 binomials, when you multiply these 2 binomials, the result is this one. So this one is an identity. This into this is equal to this is an algebraic identity. See, this is what you see here is the identity. Here, this part is how the identity is derived. So for that, we're just taking the left-hand side. We're just taking the left-hand side and finding the product. And when you do so, you get the right-hand side as the answer. Correct? You get it? So to derive the identity, we take up the LHS, we find the product, and you see that the result is the RHS. Everywhere we did that. See, we took up the LHS, a minus b the whole square. We work this one. What is a minus b the whole square? See, this is the identity. To derive this identity, we take up only the left-hand side, a minus b the whole square. What is a minus b the whole square? A minus b into a minus b. Then we find the product. And you see that the result is a square minus 2ab plus b squared, which is the RHS. Here, in this identity, we take up the LHS, a plus b the whole square. This is the left-hand side. We work the left-hand side. So what is a plus b the whole square? A plus b into a plus b. We find this product. And you see that the result is a squared plus 2ab plus b squared, which is the RHS. So when you work the LHS, the result you get is the RHS. So together it makes an identity. LHS is equal to RHS. So this is an algebraic identity. Again, familiar. A plus b into a minus b is equal to a squared minus b squared. A plus b into a minus b is equal to a squared minus b squared. So let's take up the left-hand side, find the product. How do you find the product? First term a multiplied with the second bracket a minus b. Second term plus b multiplied with the second bracket a minus b. Right? Okay. A into a squared. A into minus b minus ab. Plus b into a plus ab. Plus into minus minus b into b squared. B into b squared. A into a squared. A into minus b minus ab plus b into a plus ab plus b into minus b squared. Minus ab plus ab. So we are left with these 2 terms, a squared minus b squared, which is the RHS. A squared minus b squared. So a plus b into a minus b is equal to a squared minus b squared. So from here, the identities are new to you. 1 to 4, you've seen them in standard 8. From now, you will be seeing some new identities of 9th standard. So a plus b the whole square, sorry, a plus b plus c the whole square is equal to a squared plus b squared plus c squared plus 2 of ab plus bc plus ca. A plus B plus C the whole square. So how many terms do we have here? 3 terms. So this is a trinomial. So we say this is square of a trinomial. Square of a trinomial. Trinomial meaning 3 terms. Square of a trinomial. So when you square this trinomial, the result is a squared plus b squared plus c squared plus 2 of ab plus bc plus ca or ac. All right. So we'll see how we get this identity. So we'll in a take up the LHS as always. Take up the LHS a plus b plus c the whole square. Now here for b plus c, use a different variable d. Let b plus c be equal to d. Or you can even say let a plus b be equal to d, anything. Okay. So we'll understand this first and then you can make out the variations yourself. So here let b plus c be equal to d or any letter x, y, z, any letter. Okay. So if this is d, so this becomes a plus d the whole square, correct? If you call b plus c as d, then this becomes a plus d the whole square. See, we take up the LHS. This is the left hand side. A plus b plus c the whole square. You need to work the left hand side, and the result you get should be the right hand side. So that means if the left hand side is equal to the right hand side, you have derived the algebraic identity. Okay. So a plus b plus c the whole square. Let b plus c be equal to d. So there's nothing but a plus d the whole square. Now expand this. You know how to expand this. What is a plus d the whole square? A square plus 2ad plus d square. Like a plus b the whole square. Like a plus b the whole square. A square plus 2ab plus b square. So here it will be a square plus 2ad plus d square. Okay. Now put it back. What is d? B plus c. Put that back. D is b plus c, right? So now when you have d, put b plus c. Okay, so replace d with b plus c. So a square 2 into a into what is d? B plus c plus d square, b plus c the whole square. Let me finish. Okay. Now a square. Now how do you multiply? 2a into b, 2ab. 2a into c, 2ac. And what is b plus c the whole square? B square plus c square plus 2bc. Okay. Now, how many terms do we have in all? 1, 2, 3, 4, 5, 6 terms we have. Now, they're all unlike terms. You cannot simplify them by adding or subtracting. They're all unlike terms. A square, 2ab, 2ac, b square, bc, c square. Unlike terms. So they cannot be simplified further. So just arrange it. You know, a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ca. Okay, arranging the terms like this. All right, a square plus b square plus c square plus 2ab plus 2bc plus 2c. So you can also remember the identity like this. A plus b plus c the whole square is equal to a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ca. You can also remember like this. Or when you take out 2 common between the last 3 terms, if you take out 2 common, then it is a square plus b square plus c square plus 2 into ab plus bc plus ac. You can remember like this. Then you know when you take out 2 common, it will be a squared plus b squared plus c squared plus 2 into ab plus bc plus ac. Right? Yeah, you want to ask something. No, as of now, we only know how to square a binomial. Okay, so we have 3 terms. It's a plus b plus c the whole squared is the square of a trinomial. At this point, we only know we only know how to expand the square of a binomial. If we have two terms squared, we know how to expand. But three terms in the bracket squared, we do not know how to expand. That's what we're finding now. So because we have three terms here and we don't know the formula to expand this, we make these three terms look like two terms by replacing b plus c with d. So when it becomes a plus d the whole square, it becomes a binomial, the square of a binomial. And you know the identity, how to expand something that looks like a plus b the whole square. You know that. So we convert, since we have three terms squared, and at this point we don't know how to square a trinomial. We are deriving it. So we make use of something which we know. We know how to square a binomial. So we are converting these three terms to two terms with the help of this assumption. And now you know how to square a trinomial. Now you know how to square a trinomial. Next identity. A plus b the whole cubed is equal to a cubed plus 3a square b plus 3ab squared plus b cubed. Or between these two terms, 3ab is common. Between these two terms, 3ab is common. So when you take out 3ab common, 3ab into a is 3a square b. And 3ab into b is 3ab square. So you have to remember the identity both the ways. Sometimes, mostly for, okay, I'll tell you when we come across questions, meaning when we take up situations, I'll tell you when to use them. So remember both. Remember this as well as this. This is the identity. Upon taking 3ab common between these two terms, it's like this. Okay. So a plus b the whole cube is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. So when it is a plus b the whole cube, there is a cubed and b cubed. Okay, and then the middle terms are 3a squared b and 3ab squared. Easy to remember, no? Like when you expand a plus b the whole square, the middle term is 2ab. When you a plus b the whole squared, the middle term is 2ab. Here it is, the coefficient is 3. The numerical coefficient is 3. Just remember a plus b the whole cubed. So the numerical coefficients are 3 here. All right. So when you take out 3ab common between these two terms, 3ab common between these two terms, 3ab into a is what? A into a is a squared, right? So 3a squared b. And then 3ab into b is 3ab squared. Correct? Okay. So now we'll see how we derive this identity. Take up the LHS, a plus b the whole cubed. Okay. So what is a plus b the whole cubed? It's a plus b the whole squared into a plus b. So like 5 cubed is 5 square into 5. 5 cubed is 5 squared into 5. Similarly, a plus b the whole cube is a plus b the whole square into a plus b. Okay. Now what is a plus b the whole square? A squared plus 2ab plus b squared into a plus b. Now multiply. This is a trinomial, 3 terms. This is a binomial, 2 terms. So when you multiply a trinomial with a binomial, 3 into 2, the product will have 6 terms. The product will have 6 terms. This is a trinomial, 3 terms. This is a binomial, 2 terms. So when you multiply a trinomial with a binomial, 3 into 2, the product will have 6 terms. Okay. Now how do you multiply? The first term in the first bracket, a square, multiplied with the second bracket, a plus b. The second term in the first bracket, plus 2ab, multiplied with the second bracket, a plus b. Every term of the first bracket must be multiplied with the second bracket. Every term, how many terms are there in the first bracket? 3 terms. Every term of the first bracket should be multiplied with the second bracket. So see here, every term a squared plus 2ab plus b squared. A squared. Please look at the board. Okay. So every term of the first bracket, a squared 2ab b squared, a squared plus 2ab plus b squared, is multiplied with the second bracket a plus b. It's multiplied with the second bracket a plus b. All right. Now a squared into a cubed. A squared into b. See, it's plus a squared into plus b. See, for 7th and 8th students, when we multiply, I also read out the signs. Now, when I face a class of 9th standard, I'm not getting it like so much in detail. I'm just telling you roughly because you already know how to multiply. See, if this were a class of 7th standard students, then I'll be like plus a square into plus a, plus into plus, plus a square into a cube. It goes like that. But looking at, I cannot go in that pace. No, then it will be boring for you because you know that. Okay, so a squared into a cubed. Signs also we multiply. When you multiply two terms, you are multiplying their signs first and then the terms. Every term has a sign attached to it. If there's no sign, that means it's positive. So whenever you multiply two terms, you're multiplying their signs first. Plus into plus, plus, or plus into minus, minus. So first you multiply the signs, write that, and then you multiply the terms. Okay, let me do that way. So a squared and a. What are the signs? Plus a squared plus a. So plus into plus, plus. A squared into a cubed, plus a cubed. Then here, it's plus everywhere, children, so it will be plus everywhere, okay? So a squared into b, a squared b. Then 2ab into a, 2a squared b. 2ab into b, 2ab squared. B squared into a b squared. B squared into b, b cubed. B cubed. Correct? Okay. Now let's look out for like terms, if any. A squared b, like terms. B squared, like terms. So you can simplify this and this and this. 1a square b, 2a square b. So 3a square b. Correct? 1a square b, 2a square b is 3a square b. So 3a square b. 2ab square, 1ab square. 2 plus 1, 3. 3ab square and b. So now because we see the product, we got 6 terms. 1, 2, 3, 4, 5, 6 terms. 3 into 2, 6 terms we have. Then since we have like terms, on simplifying, now the result has only 4 terms. A cube, so a plus b the whole cube is equal to a cube plus 3a square b plus 3ab square plus b cube. Now when you take out 3ab common between these two terms, 3ab common, then the identity looks like a plus b the whole cube is equal to a cube plus 3ab into a plus b cube. Because 3ab into a is 3a square b, 3ab into b is 3ab square. All right. Any questions, Sanjay? Any questions? No. Yeah, same result you get. That is a plus b into the other way, is it? Yeah, multiplication is commutative, right? Like 5 into 3 is equal to 3 into 5. So you will get the same result. Next identity, a minus b the whole cubed. A minus b the whole cubed is equal to, see, the signs will alternate between plus and minus. The terms are the same. A cubed, 3a squared b, 3ab squared b cubed. The terms are the same. Look at the signs. Plus, minus, plus, minus, plus, minus, plus, minus. But don't change the order, okay? So first a cubed, then 3a square b, then 3ab square, then b cubed. In this order, plus, minus, plus, minus. A cubed, that's positive, no? When you say a cubed, it's positive. A cubed minus 3a square b plus 3ab square minus b cubed. See, remember, there is no sign here, but it's plus. So plus, minus, plus, minus. A minus B the whole cubed is equal to A cubed minus 3A square B plus 3AB square minus B cubed. Now, when you take out, 3AB, minus 3AB common, minus 3AB because this is minus, no? So this A cubed as it is, and then minus, so minus, and between these two terms, 3AB is common, so 3AB. When you take out minus 3AB common, see here, 3AB into A is 3A square B, and the sign minus into plus is minus. Minus into plus, minus. Now this is plus 3AB square. So minus into minus is plus. So you should take a minus inside the bracket. Minus here. Why? Because minus into minus is plus. And 3AB into B is 3AB square. Minus 3AB into minus B. Minus into minus plus 3AB into B, 3AB square. Plus 3AB square. Plus 3AB square. Minus 3AB into A. Minus 3AB into A. Minus 3AB into A is equal to minus into plus minus A into A square. So minus 3A square B. Correct? Yeah. So see, so be careful with this. Minus into minus only will give you plus. So it is minus 3AB into A minus B. So remember both of them. So the second one is A cubed minus 3AB into A minus B cubed. A cubed minus 3AB into A minus B cubed. Now we'll see how it's derived. So A minus B the whole cubed is A minus B the whole square into A minus B. Now what is A minus B the whole squared? A squared minus 2AB plus B squared into A minus B. Now trinomial, 3 terms, binomial, 2 terms, 3 into 2, 6 terms. The product will have 6 terms. How do you multiply? First term, every term of the first bracket should be multiplied with the second bracket. Every term of the first bracket should be multiplied with the second bracket. So every term, A squared minus 2AB plus B squared is multiplied with the second bracket, A minus B, A minus B. Now multiply the terms, A squared into A cubed. A squared into minus B, minus A squared, minus 2AB into plus A, minus 2A square B, minus 2AB into minus B, minus 2AB into minus B, minus into minus plus 2AB square. B square into A. I've just written A in the alphabetical order, A and then B. Okay, so A, B square. Then plus B square into minus B is minus B cubed. B square into B is B cubed plus into minus minus. So like terms, these two are like terms, these two are like terms. All right, so minus 1A squared B minus 2A squared B is minus 3A squared B. Plus 2AB square plus 1AB square plus 3AB square. Okay. Like terms. So this is minus 3A square B. This is plus 3AB square, then minus B cubed. A cubed and A cubed minus B cubed as it is. These two terms here, these two terms here. So 6 terms reduces to 4 terms. Now the two middle terms have 3AB common. Since the second term has minus sign here, so it will be minus 3AB common. Whatever is the sign here that comes down, A cubed, this minus as it is, common is 3AB. Now minus 3AB into A is minus 3A square B, minus into minus plus. When you multiply these two, you get 3AB square. All right. Okay. Now there's a difference between a plus b the whole cubed and a cubed plus b cubed. They're not the same. Like a plus b the whole square and a square plus b square, they're not the same. They're not the same. A plus b the whole square. See the order in which we calculate. When it is a plus b the whole square, you'll have to add a and b and then square the result. What do we mean by a plus b the whole square? Add a and b, that result should be squared. But what is a squared plus b squared? Square a, square b, and then add. Then add. So the order in which you're carrying out the operations are different. So the answer will definitely be different. A plus b the whole square, you need to add and then square. In a squared plus b squared, you'll have to square and then add. The results will vary. See, rarely for some numbers, both the answers may be the same, but it will not be the same always. So a plus b the whole square is not the same as a square plus b square. They're different. In the same way, a plus b the whole cube means find the sum a plus b and then cube the sum. Add and then cube. Here cube and then add the cubes. So they're different, so don't get confused. This is a cubed plus b cubed, not a plus b the whole cube. A cubed plus b cubed. So a cubed plus b cubed is equal to a plus b. See the terms you get. So see, I'll show you the next one also. So this is a cube plus b cube. Next slide, a cube minus b cube. Okay. Then in a cube plus b cube, it is a plus b, a squared minus ab plus b squared. Here it is a minus b, a squared plus ab plus b squared. See, it's easy to remember. When it is a cube plus b cube, the first bracket will be a plus b. A cube plus b cube, the first bracket is a plus b. When it's a cube minus b cube, the first bracket is a minus b. Then here, the middle term, when you start with a plus b, the middle term will be negative. When you start with a minus b, the middle term will be positive. So now let's write it. Let's just look at the terms a minus ab, then a square, b square. Okay, we'll try to write. Okay. Yeah. So we are talking about a cubed plus b cubed and a cubed minus b cubed. Okay. A cube plus b cube. So the first bracket will have a plus b. A cubed minus b cube. The first bracket will have a minus b. The terms in the second bracket are a square, ab, and b square. Okay. A square, ab, b square, not 2ab. A square, ab, b square. So it will be a. Now here it's plus, no? So this ab, this will be minus. This is plus. A square and b square are always positive. Only the middle term. The middle term. A square plus b square. The middle term. It's a plus b here. So it will be minus ab. Here it will be a square plus ab because it's minus here. No? So it will be plus ab plus b square. You're Anita, right? Yeah, you're Anika. Anika. KH. Yeah. Now, Anika, tell me Anita, tell me the first one. Come, don't get up. Sit down, sit down. Expand a cubed plus b cubed. A squared b squared. B squared. Correct. Anika, a cubed minus b cubed. Anybody wants to correct this? Plus AB. Plus AB. If with a minus here, it will be a plus here. With a plus here, it will be a minus here, the middle term. Sanjay, tell us both. நீங்க மட்டும்தான் சஞ்சய் கிளாஸ்ல வேற யாரும் இங்க சண்டே இல்லையே நீங்க சண்டே தானே சொல்லுங்க don't get up. Complete the identities a cubed plus b cubed and a cubed minus b cubed. Complete the identities. You can write and read it out from your book. Yeah, if you're whichever way you're confident. First one முடிச்சிருப்பீங்க சொல்லுங்க. Very good. Next one. Is a minus b into plus ab. So you're right. Plus b square. Very good. Okay. Now we'll see how it's derived. Okay. Now to derive this, you need to take up the LHS. You need to take up that side where you can work something. Now this is very simple, a cube plus b cube. Take the other side. Here you can find the product, right? So take up the RHS here. Take up this side. And when you work this side, the result should be a cube plus b cube. When you work this side, normally we take the left-hand side of the identity. We work this one and we arrive at this result. So here we'll be taking up the right-hand side of the identity, this one. We'll work this and we'll get these terms as the result. So a plus b, the right-hand side, a plus b into a squared minus ab plus b squared. It's a product. So you should multiply all the terms of the first bracket with the second bracket. All the terms of the first bracket. How many terms? A and b. Two terms. Two terms, a and b, multiplied with the second bracket. This is the second bracket. Okay. So now. So we take up the right-hand side. A plus b into a squared minus ab plus b squared is equal to, yeah, Krish. First step in. Yes. Yeah, next, Novid. Continue fast. Sign order சொல்லணும். Very good. Next. Sanjay. No, I'll come from here. Yarni. Yeah, continue. Fast. Don't waste time. Stop, stop. Yeah. Yeah, you, sorry, you. Plus b cube. Yeah, continue. You can, Smriti, continue. Very good. Minus a squared b. plus a squared b, 0. Then plus ab square minus ab square, 0. Plus ab square minus ab square, 0. So you're left. So we had 6 terms. See, this bracket has 2 terms, this one 3 terms. So when you multiply, we got 6 terms. 1, 2, 3, 4, 5, 6 terms. Of the 6 terms, 4 terms cancelled out. And we are left with a cubed plus b cubed. A cubed plus b cubed. See, we proved a cubed plus b cubed is equal to a plus b into a squared minus ab plus b squared. Similarly, the RHS of the other one, a minus b into a squared plus ab plus b squared. Yeah, start, Anika. Tell me, what do we, louder. Louder. No, first is to present the multiplication. Yeah. A into எங்க minus AB? Yeah, Shreya, continue. Shreya.
Yes, ma'am.
Yeah, continue.
A cube plus a square b plus ab square
Okay.
minus a square b minus ab square.
Minus or plus?
It's plus into minus into plus, which is minus, right, ma'am?
Very good, very good. Minus, plus into minus, minus. Yes.
So ab square minus b cube.
Very good. Next. No. Gayatri, can you answer?
Yes, ma'am.
Yeah, continue. Yeah.
Ma'am, a square plus a square b and minus a square b cancels, ma'am.
Okay.
Plus ab square and minus ab square. So it's a cube minus b cube.
A cube minus b cube. All right. So a cube minus b cube is equal to a minus b, a square plus ab plus b square. Very good. So that's what you have here. Here and here. Okay. Yeah, there's the next one. A cube plus b cube plus c cube minus 3abc. A cubed plus b cubed plus c cubed minus 3abc. What happened? Okay. A cube plus b cube plus c cube minus 3abc is equal to a plus b plus c into a squared plus b squared plus c squared minus ab minus bc minus ac or ca. Okay. When you multiply a plus b plus c with a squared plus b squared plus c squared minus ab minus bc minus ac, you will get this expression as the product. When you multiply this with this, the product is this one. Let's write it again. A cubed plus b cubed plus c cubed minus 3abc is equal to a plus b plus c into a squared plus b squared plus c squared minus ab minus bc minus ca or ac. So you need to find the product of these two brackets. So this bracket has 3 terms. This one has 6 terms. So when you multiply, you will get 18 terms. Of the 18 terms, you are left with only 4 terms here. So 14 terms will be cancelled out. All right. So this I want you to help yourself and present it. All of you just do it behind your book because you have the first few things to complete, right? So just practice behind your book. Don't look at this one now. We'll see this later. Not this one now. Not this one. Only this part. Only the first part here. Practice this one. Not this. Online children can use a rough notebook. This is the identity. Try to multiply the terms in these two brackets and arrive at the correct result like this. Got it? Okay. So you need to find the product of these two expressions. So every term in the first bracket should be multiplied with the second bracket. Every term in the first bracket has three terms, A, B, and C. So you can see A multiplied with the second bracket, B multiplied with the second bracket, C multiplied with the second bracket. Every term of the first bracket should be multiplied with the second bracket. Then you need to find the product of the terms like this, right? Correct? Okay. So we know when you multiply this expression which has three terms with this expression which has six terms, the product will give you 18 terms. Okay, you'll have 18 terms in the product. Now, plus AB squared, yeah, plus AB squared minus AB squared cancels. Then plus AC squared minus AC squared. Oh, no. AC square, yeah, this is AC square, yeah, all right. And then minus A squared B, whereas plus A squared B, yeah, plus A squared B. And then minus A square C plus A square C. Plus BC squared minus BC squared. Okay, see, you need to, you'll have only these four terms, A cubed plus B cubed plus C cubed, and then minus 3ABC, right? So you'll have minus ABC, minus ABC, minus ABC. That will make minus 3ABC. A cubed plus B cubed plus C cubed. And with that, you should have one minus 3ABC term. Minus ABC, minus ABC, minus ABC is minus 3ABC. So see here, minus ABC, minus ABC, minus ABC. Minus 1 ABC, minus 1 ABC, minus 1 ABC is minus 3 ABC. All the other terms will get cancelled. Now, yeah, minus B squared C plus B squared C. So see, everything cancelled. You'll get 18 terms. When you multiply, you get 18 terms. Okay, of the 18 terms, you will see A cubed plus B cubed plus C cubed, which is a part of the result. And then you also need minus 3 ABC. And that is from minus ABC, minus ABC, minus ABC, minus 3 ABC. The rest of the terms will get cancelled. Okay. You need to cancel. I haven't cancelled here. You need to cancel, like what I just showed you. You should cancel. Is that fine, children? Okay. I've repeated typing this. Is equal to A cube plus B cube plus C cube minus C cube. See, by mistake, I've typed it again. So this is again a very important identity. A plus, tell me. A plus B plus C into what? A squared plus B squared plus C squared minus AB minus C minus CA is equal to, I've written it the other way around. A plus B plus C into A squared plus B squared plus C squared minus AB minus BC minus CA is equal to A. Yeah. Okay. Yeah. Online children, any questions?
No questions, ma'am.
No,
Okay.
ma'am.
I'll let you know. Okay. So in the same slide below, you see this conditional identity. Conditional identity is, now in this identity, if A plus B plus C is 0, okay, in this identity, if A plus B plus C is 0, then what is the value of A cube plus B cube plus C cube minus 3ABC? See here. In this identity, if the value of A plus B plus C is 0, then what is A cube plus B cube plus C cube minus 3ABC? 0. 0, because 0 into anything is 0, right? You're completing your school homework or something? Okay. Hmm. Okay. So in this identity, if the value of a plus b plus c is 0, what is 0 into the second bracket? 0. So we have a cube plus b cube plus c cube minus 3abc is equal to 0. A cube plus b cube plus c cube minus 3abc is equal to 0. So a cube plus b cube plus c cube minus 3abc is equal to 0. Now when you take this to the other side, a cube plus b cube plus c cube is equal to 3abc. Minus 3abc when you transpose, when you take it to the other side, plus 3abc. So the conditional identity is if a plus b plus c is 0. Yeah, I have it on the next slide. I proved it in a different way on the next slide. If a plus b plus c is 0, then a cubed plus b cubed plus c cubed is equal to 3abc. See, I'll repeat. We know this identity now. Now in this identity, if the value of a plus b plus c is 0, then we have a cube plus b cube plus c cube minus 3abc is equal to 0, because 0 into anything is 0. Okay, now that we have a cube plus b cube plus c cube minus 3abc is equal to 0, when you transpose, we have a cube plus b cube plus c cube is equal to 3abc minus 3abc on the other side plus 3abc. All right. Now this identity is called the conditional identity. And how do we present the identity? We say if a plus b plus c is equal to 0, then a cubed plus b cubed plus c cubed is equal to 3abc. It's a conditional identity because a cube plus b cube plus c cube is equal to 3abc only if a plus b plus c is 0. Only when a plus b plus c is 0, then a cube plus b cube plus c cube is equal to 3abc. So you can understand this conditional identity using this identity. Like what I just explained, if this is 0, then this whole thing becomes a 0. And when you transpose this, you get a cube plus b cube plus c cube is equal to 3abc. But it can also be derived independently like this. Okay, the conditional identity can also be derived independently without the help of this identity, like this. So the conditional identity is if a plus b plus c is 0, then a cube plus b cube plus c cube is equal to 3abc. So what we do? Take the condition given a plus b plus c is equal to 0. Then transpose any one term to the other side, any one term. You can take c to the other side or b to the other side or a to the other side. Take any one term to the other side. So I have taken c to the other side. So we have a plus b is equal to minus c. Take any one term to the other side. Now cube on both the sides. Why should you cube? Because the result is a cubed plus b cubed plus c cubed is equal to 3abc. That's the result you need to show. So you have to cube on both the sides. Cubing on both the sides. So we have a plus b the whole cubed is equal to minus c the whole cubed. Now what is a plus b the whole cubed? We just learned the identity. A cube plus b cube plus 3ab into a plus b. I think I told you like this, a cubed plus 3ab into a plus b cubed. I'll show you. Yeah, here. A cubed plus 3ab into a plus b cubed. A plus b the whole cubed is a cubed plus 3ab into a plus b cubed. Okay. Yeah. So a plus b the whole cubed is equal to a cubed. I've just changed the order. See, a cube plus 3ab into a plus b cube. Since all, I've just written in a different order. A cubed plus 3ab into a plus b cube is equal to what is minus c into minus c into minus c? Minus into minus plus, plus into minus minus. c cubed, minus c cubed. Because minus c the whole cube means minus c the whole cube means minus c into minus c into minus c. Minus into minus plus, plus into minus minus, c into c, c squared, into c, c cubed. So we have minus c cubed here. Now we know that a plus b is equal to minus c. See, a plus b is equal to minus c. See, a plus b is minus c. So here, instead of a plus b, we use minus c. Because a plus b is equal to minus c. So a plus b is replaced with minus c. So now we have a cube plus b cube, plus into minus minus, 3ab into c is 3abc, is equal to minus c cube. Now transpose. Like arrange the terms accordingly so that you are able to show this result. So a cubed plus b cubed plus c cubed transpose is equal to plus 3abc. Just exchange these two terms. Transpose. Bring this to the left hand side, take this to the right hand side. So minus 3abc becomes plus 3abc. Minus c cubed. When it goes to the left hand side, plus c cubed. So a cube plus b cube plus c cube is equal to 3abc. All right. Okay, so these we'll see in the next class. Too much of ABC has happened now, so we'll see these in the next class. But with this, you've been introduced to all the identities which you will be using in standard 9. Okay. So we'll now list all the identities. We'll see how much we can recall. Yeah. What is a plus b the whole square? We started with this one. Yeah, one second. Yeah. Haridarshan, a minus b the whole square.
A plus B plus A minus B, ma'am.
No. A minus b the whole square. Lakshana?
Ma'am, A square minus 2AB plus B square, ma'am.
Correct. Then what is, then you said a plus b into a minus b, right? What is this? What is a plus b into a minus b?
Identity tree, ma'am.
Huh?
Identity tree, ma'am.
Correct. Complete the identity. A plus b into a minus b is equal to?
A square minus B square.
A squared minus b squared. Very good. Thank you. What's the fourth one we saw? X plus a into x plus b. X plus a into x plus b is equal to? X squared plus a plus b of x plus ab. Harsha, are you there? Harsha? Okay, somebody online complete this. What is a plus b plus c the whole squared?
Mom, a square plus b square plus c square
Yeah.
plus 2 into ab plus bc plus ca.
Very good. Very good. Yeah, here. Complete this one. Somebody here. A plus b the whole cube. A plus b. Very good. Tell me all the four terms separately. A cubed plus 3a squared b plus 3ab squared plus b cubed. B cubed. A cubed plus 3a squared b plus 3ab squared plus b cubed. Now, what's common between these two terms? 3ab. 3ab is common. Then you will have in the bracket a plus b plus b cube. What's a minus b the whole cube? A cubed minus 3a squared b plus 3ab squared. What's common between these two terms? Minus 3ab. In the bracket, a minus b and minus b cubed. B cubed. A cubed minus 3ab into a minus b minus b cubed. Yeah. A cubed plus b cubed is equal to
A plus B into A square minus AB plus B square.
not minus 2ab, minus ab.
Minus AB plus B square.
Correct. Correct. Minus ab plus b squared. Very good. What's a cubed minus b cubed?
A minus B into this plus B square.
Very good. Very good. Then what is a cubed plus b cubed plus c cubed minus 3abc? Very good. And the conditional identity, if a plus b plus c is equal to 0, then a cubed plus b cubed plus c cubed is equal to 3abc. If a plus b plus c is 0, then a cube plus b cube plus c cube is equal to 3abc. All right. So this is all about the identities you will have in the standard. We'll do the second one. We'll do the second one. Find the quotient and remainder. That's of 8th standard. This question is of 8th standard. Find the quotient and remainder when p of x. So this is how we name a polynomial. P of x. P of x is the way we name a polynomial. So in the bracket, we specify the variable. X is the variable. X is the variable. So in the bracket, we specify the variable. And outside, we use any small letter from A to Z. Any small letter. It's not capital P of X. It's small p. Okay, you cannot use x of x like this. You cannot use. If the variable is x, you cannot use x again outside. Okay, so you can call the polynomial g of x, f of x, p of x, r of x, like this. If the variable is y, then it will be g of y, f of y. If the variable is z, then r of z. In the bracket, you should specify the variable in the polynomial. Now, this is a polynomial in one variable x. This is a polynomial in one variable x. And it is a cubic polynomial because you can see the highest power is 3. So it's a cubic polynomial. Okay, so this one is called p of x. And this is another polynomial, x minus half is another polynomial. And this one is a linear polynomial because the power of x is 1. The power of x is 1. It's a linear polynomial. Now we're going to divide this cubic polynomial by this linear polynomial. This linear polynomial, see, x minus half, don't get confused with half. X is the variable. Somebody's mic is enabled. Please disable your mic. Hari Darshan, disable your mic. Yeah, thank you. Yeah, so I was telling you, x minus half, the variable is x. Its power is 1. The variable is x. Its power is 1. Whole number. It's a polynomial. No, I'm like, don't get confused with half. 1 by 2 is not a whole number, so it's not a polynomial. We look at only the powers of the variables involved, not anything else. So x is the variable. X is the variable. Its power is 1. It's a polynomial. It's a linear polynomial. And this linear polynomial is called g of x. Why x? Because x is the variable. And I told you can use any small letter before that. Okay. So 4x cubed minus 12x squared. 4x cubed minus 12x squared plus 14x minus 3 is divided by x minus half. Now we're going to divide p of x by g of x to find the quotient and the remainder. To find the quotient and the remainder. Okay, we'll do it together. Once I give you the introduction, then you will be given a lot of opportunities to try the answer by yourself. Now, since we are just getting introduced to the different concepts or different things in this chapter, I am talking a lot. Once I give you the introduction to the whole chapter, then you will get a lot of chances, a lot of opportunities to try by yourself. Now listen, okay? Yeah. So through this, we are going to understand a theorem which is called the remainder theorem. Through this division process, we are going to understand a theorem which is called the remainder theorem. Remainder theorem. All right. Okay. We'll also understand a theorem which is called the factor theorem. That's all. With remainder theorem, factor theorem, and algebraic identities, this is all we have. All this makes polynomials. These are the contents, the different subheadings in this chapter. Okay, these are the different subheadings in this chapter, polynomials. Okay, let's start the division. So we need to first check if the dividend, if in the dividend, the terms are arranged in the descending order of the powers of the variable involved. The variable is x. See, it shouldn't be 4x cubed minus 3 plus 14x minus 12x squared. If the dividend is this, you should arrange it correctly. You must arrange the terms correctly. What does that correctly mean? Correctly means starting from the highest power of x to the lowest power of x in the descending order. We can also arrange it in the ascending order. But in schools and, even we used to do it in the descending order. That's how we do it. We can also do it in the ascending order. But we'll be doing it like this. How? We'll arrange the terms in the descending order of the power of x. So 4x cubed first. 3 is the highest power. Then 12x squared. Not this number 4 and this number 12. X is the variable power 3. X is the variable power 2 plus 14x. X is the variable power 1. And then the constant minus 3. Power 3, power 2, power 1, and then the constant. It's not, see, supposing you have 4x to the power 7, and then you don't have x power 6, that is okay. Then supposing after this you have only power 4, then write that power 4. Then after this you may have only 2. You might not have 3, power 3. That is fine. Whatever powers are available, arrange them in the descending order. Am I clear? Okay. So in the question itself, the terms are arranged in the correct order. So you can see power 3, power 2, power 1, and then the constant. The same thing with the dividend. Sorry, divisor. This is the dividend. Same thing with the divisor. First x power 1 and then the constant. Supposing the dividend were 5 minus x. You should not take it like that. It should be minus x plus 5. Yes. If the dividend, sorry, divisor. If the divisor were 5 minus x, the order is incorrect because x should come first and then the constant. X should come first and then the constant. So you should write this as minus x plus 5. If you divide this one with 5 minus x, your division is wrong. Your division will be wrong. You will go wrong with the division. Am I clear, children? So you should arrange it both in the dividend and the divisor. Okay, now let's begin. Division is very easy. First term of the dividend divided by the first term of the divisor. Do it in the rough column. 4x cubed divided by x. First term of the dividend divided by the first term of the divisor. 4x cubed. This is the dividend. This is the divisor. What you get here is a quotient. What you will get here is the remainder. This is the dividend. This is the divisor. First term of the dividend divided by the first term of the divisor. What do you get? 4x squared. This is the first term in the quotient. This is the first term in the quotient. All right. Now multiply. See what you normally do, children. 15. So 3 5s are 15. So you multiply this and this, right? 3 5s are 15, 0. That's what you should multiply this and this now. That's what we always do with numbers also. We multiply 3 into 5, 15. We write the product here. Same thing here. Multiply x minus half and 4x squared. Okay. So multiply 4x squared and x minus half. You want any help, Rahul? Do you want any help? Okay. So 4x squared into x minus half. All right. Multiply 4x squared, the quotient. It's called the partial quotient with the divisor x minus half. All right. Now, how do you multiply this into this? 4x squared into x, 4x cubed, 4x cubed. Write that here, 4x cubed. Then 4x squared into minus half. 4x squared into minus half. So 2 1s are, 2 2s are. 2x squared into minus 1. So minus 2x squared. Just want to do it again. 4x squared into x minus half. When you multiply this and this, you get 4x cubed. When you multiply this and this, 4x squared and minus half, 2 1s are, 2 2s are. 2x squared into minus 1. So minus 2x squared. Minus 2x squared. Write that here. 4x cubed minus 2x squared. Write the product here. Okay. Now what do? Subtract. We always subtract. In division, we always subtract. When we multiply, we add. When you multiply 14 into 15, what do? 5 4s are 20, 2 carried over, 5 1s are 5, 7. Then you put a multiplication sign here, then 4 1s are 4, 1. Then you'll add, no? 0, 7 plus 4, 11, 1 carried over, 2. When you multiply, you add. You add the digits. Now here, when you divide, even with numbers, when you divide 110 by 3, 3 3s are 9. Then you'll subtract, no? Will you do 11 plus 9, 20? What do? 11 minus 9, 2. You subtract. When you divide, you subtract. You don't show the minus sign, but you will actually subtract, right? Same thing here, you should subtract. But when you're subtracting expressions, you should change the signs. See here, when I wrote 11 and 9, it's 11 minus 9, 2, right? But you didn't show the minus sign. But here in expressions, you must show the sign. So when we subtract, what we do is we change the signs in the second expression. 4x cubed plus 4x cubed becomes minus 4x cubed. Plus 2x squared becomes, minus 2x squared becomes plus 2x squared. Why we change the signs is because it's division, we have to subtract. And when we are handling expressions, if we have to subtract, in the second expression, the second row, we'll have to change the signs, right? The opposite sign. If it's plus, make it minus. If it's minus, make it plus. When you do that, you're subtracting. So we change the signs because we have to subtract. Now, plus 4x cubed minus 4x cubed, 0. So gets cancelled. Now, minus 12x, take the new sign. Minus 12x squared plus 2x squared. Minus 12x squared plus 2x squared. What is that? Minus 10x squared. Then bring the remaining terms down. The remaining terms. You can bring all the terms down. Now repeat this procedure. Divide the first term. This is called the new dividend. This is called the new dividend. Because this was the dividend earlier, right? Now this is the new dividend. Divide the first term of the new dividend with the first term of the divisor. So now it is minus 10x squared divided by x. All right. Okay. So now what is the result? Minus 10x. 10x. Next what? No, 10x, no, because x squared by x is x. Minus 10x, minus 10x. Next what? We need to multiply. What do we always do? We multiply this and this, right? We should multiply this and this and write the result here. Yeah. Multiply. Should multiply minus 10x and x minus half. So when you multiply these two terms, you get minus 10x squared, minus 10x squared. And when you multiply these two terms, minus into minus plus, then 10x into half. 2 1s are 2 5s, 5x, 5x. So write them here. Write the terms here. Now we have to subtract, which means we'll have to change the signs of all the terms in the bottom row, the second row. Minus becomes plus, plus becomes minus. So now minus 10x squared plus 10x squared, 0. Let's cancel. Plus 14x minus 5x. Just a moment. 1 second, children. Yeah, children. Okay, so plus 14x minus 5x, 9x, and minus 3 comes to. So we have no more terms. So this will be the last stage in the division process. So this is called the new dividend. This is the new dividend. 9x minus 3 is a new dividend. So divide the first term of the new dividend with the first term of the divisor. You can see everywhere it's divided by x only. Everywhere we divide by x. First we divide 4x cubed by x, then minus 10x squared by x, and now 9x by x. What's 9x by x? 9x by x, 9. 9x by x is 9, so plus 9. 9 means plus 9. Yeah, 1 second. So now we'll have to multiply. Multiply 9 with x minus half. 9 into x minus half. 9 into x is 9x. And 9 into minus half. Excuse me. Is 9 by 2. 9 by 2 or 4.5. 9 by 2 or 4.5. Minus 4.5. Minus 9 by 2 or 4.9 into half, children. 9 into minus half. So it will be 9 by 2 minus 9 by 2 or minus 4.5. Excuse me. Now change the signs. Change the signs. All right. Cancels. Minus 3 plus 4.5 is plus 1.5. So 1.5 is the remainder, or 3 by 2 is the remainder. 1.5 or 3 by 2 is the remainder. So that means the dividend is not a multiple of the divisor, or the divisor is not a factor of the dividend. Like we conclude in numerical situations when now 27. When you divide 27 by 3, 3 9s are 27, 0 is a remainder. So what's the conclusion? 27 is a multiple of 3, or 3 is a factor of 27. Why? Because on dividing the remainder is 0. On dividing of the remainder is 0, you can make two statements. One is 27, since on division the remainder is 0, it means the dividend 27 is a multiple of the divisor 3. 27 is a multiple of 3, or 3 is a factor of 27 because the remainder is 0. But if it were like this, 3 9s are 27, 1 is a remainder. So 28 is not a multiple of 3. 3 is not a factor of 28 because the remainder is not 0. 3 is not a factor of 28. 28 is not a multiple of 3. In the same way here, this one is called P of x, right? And this one is called G of x in the question. P of x is not a multiple of G of x. G of x is not a factor of P of x. P of x is not a multiple of G of x. G of x is not a factor of P of x because the remainder is not 0. It's something, it's not 0. So no multiple, no factor. So if you have to find the remainder on dividing P of x by G of x, it takes this long. It might be more complicated also depending on the terms we have in the dividend. If the coefficients are fractions, like 7 by 9 and 11 by 3, if the coefficients of x square and x are fractions, then it makes the division process all the more time consuming. The procedure will be the same, but you will take a little more time in calculating, no, when the coefficients are fractions. So now we are going to learn how to find the remainder. How to find the remainder when P of x is divided by G of x without performing the long division process. How did we find the remainder now? By using the long division. We're going to see how to find the remainder without doing the long division in less time. If this take, that is next. That's next. So we're going to see how we can find the remainder. When you disturb me, I'll forget what I have said. We're going to see how we can find the remainder in lesser time. Now, this division process, probably some 10 minutes we took. Okay, if we went wrong somewhere, we'll even land up in 15, 20 minutes. But you can easily find the remainder in less than 5 minutes using the remainder theorem. But to use the remainder theorem, okay, so why use the remainder theorem? To find remainder in less time. But there are some conditions. Okay, if you want to find the remainder in less time without doing this long division process, you can use the remainder theorem. But there you have some conditions to be satisfied by P of x and G of x, that is by the dividend and divisor. P of x, which is the dividend, okay, can be of any degree greater than 1. Let me just go back to this. See here in our question here, look at P of x, it's a cubic polynomial. Look at G of x, it's a linear polynomial. So to use the remainder theorem, the divisor should always be a linear polynomial. If the divisor is a quadratic or a cubic polynomial, you cannot use the remainder theorem. Remainder theorem can be used only if the divisor is a linear polynomial. Only when you're dividing by x minus half, x only it should be. It should not be x squared, x cubed, x to the power 4. No, only x. Linear polynomial. The divisor should be linear. This one can be anything. P of x can be of any degree greater than 1. The dividend polynomial, the dividend can be of any degree greater than 1. But this one should be of degree 1 only, linear only. Only if these two conditions are satisfied, you can use the remainder theorem. So you don't have to actually look at the dividend. You'll have to only check the divisor. Is this linear? Yes, it's linear. Yeah, then I can use the remainder theorem. You don't have to really bother about the dividend, this one. Divisor, look at the divisor. Is it linear? Yeah, it is linear. The power of x is 1. It's linear. Yeah, then you can use the remainder theorem. When to use the remainder theorem? To find the remainder. If you want to find the remainder, when a polynomial is divided by a linear polynomial, if you want to find the remainder without performing the tedious long division process, then we use a remainder theorem. But using the remainder theorem, you cannot find the quotient. If you want to find the quotient, you have to do the long division. When you divide a polynomial by another polynomial, you get two new things, no? You get something called the quotient and remainder. When you divide one thing by another, you get two new things, right? Quotient and remainder. If you want to find only the remainder, you can use a remainder theorem. If you want to find the quotient also, then you should use a long division. Okay. So here, P of x is 4x cubed minus 12x squared plus 14x minus 3. And g of x minus half. Are the conditions satisfied? Yes. This I told you don't have to worry. The divisor is a linear polynomial. So we can use a remainder theorem. Now how to use a remainder theorem? Equate the divisor to 0. Equate the divisor to 0. What's the divisor? X minus half. Equate it to 0. And solve for x. So x minus half is equal to 0. X is equal to half. X is equal to half. Okay. Now find the value of the polynomial P of x at x is equal to half. Find the value of the polynomial P of x, the dividend polynomial P of x at x is equal to half. When x takes the value 1 by 2, what is the value of the polynomial? So we are going to find P of half. P of half will give you the remainder. This is the divisor. equated to 0 and find the value of x. X is half. Now come to the dividend. Find the value of the dividend when x takes the value half, 1 by 2. When x is 1 by 2, what's the value of the polynomial? That answer is the remainder. That answer will be the remainder. Now we'll have to find p of 1. See, x is 1 by 2. So p of 1 by 2. P of x, what is x? 1 by 2. So p of 1 by 2 is equal to 4 into, what is x? 1 by 2, the whole cubed, minus 12 into, what is x? 1 by 2, the whole squared, plus 14 into, what is x? 1 by 2, minus 3. Don't write 3 as 1 by 2. Only x should be replaced with 1 by 2. Wherever there is x, use 1 by 2. So what are we doing now? We are finding the value of the polynomial p of x at x is equal to half. And this will be the remainder. So 4. Now don't cancel. See again, here you should be very careful. You cannot cancel 2 and 4 here. Because you should first find 1 by 2 the whole cubed. You must first find 1 by 2 the whole cubed. See, first things first always. Okay, so you wake up and there is your favorite coffee, tea or milk on the table. And then your toothbrush, tongue cleaner and paste. Which one first? Will you drink and then brush or you'll brush and then drink? Anyways, huh? No, right? So the right order is you brush and then drink. Yeah. So first things first, you cannot cancel 2 and 4. Because it's 1 by 2 the whole cubed first and then into 4. So no, this is not oddness. This is okay. You see 1 by 2 the whole cubed into 4. See 1 by 2 is raised to the power 3, right? So if you cancel 2 and 4, then you have not applied this power 3 to the number inside. Then how can you simplify this and this? The meaning itself is like that. When it's written like this, it means 1 by 2 should be cubed first. See here, the bracket is there and the cube is here. 1 by 2 the whole cube. Simplify this. So what does that give you? 1 by 2 the whole cube, 1 by 8. Now it's free. Now it's free. 1 by this one is now free. The power 3 is gone now. Now you can cancel 4 ones are 4 twos. So do not cancel. I shouldn't be saying do not cancel. I should say you should not cancel. You should not cancel 2 and 4. Or you cannot cancel. Okay, so it's 4 into 1 by 8 minus, same thing here. Same story here. 1 by 2 the whole squared first. 1 by 4. Don't be in a hurry to cancel. Plus, here you can cancel. Because power is 1 or there's no power like. So 2 ones are 2 sevens are. Minus 3. All right. So P of half is equal to, now cancel. 1s are 2s are. So what do you have here? 1 by 2 minus 4 1s are 4 3s are. So minus 3 plus 7. Huh? Okay, plus 4. Okay, plus 4. Then what is plus 4 minus 3? Plus 4 minus 3 plus 1. And 1 plus half, 1 and a half. Or 1.5. We got 1.5. No remainder there. Remainder we got 1.5, right? Yeah, see 1.5. 3 by 2, whatever you call it. 3 by 2 or 1.5 is the remainder. So see. So we found the remainder. So when you divide P of x by G of x, 1.5 is the remainder. So we found the remainder without actually performing the long division and in less time. But you cannot find the quotient. If you want to find the quotient and the remainder, you have to do the long division. If you want to find only the remainder, you can use a remainder theorem. So what's the procedure? First check if the divisor is a linear polynomial. Check if the divisor is a linear polynomial. Power should be 1. The variable can be x, y, z, any variable, but the power should be 1. The divisor should be a linear polynomial. Dividend can be anything. It will be more than 1. So you don't have to bother with the dividend. So So if this condition is satisfied, then you can use a remainder theorem. And for that, equate the divisor to 0. Okay, the divisor is x minus half. Equate it to 0 and find the value of x. And find the value of x. Okay, so we get x is half. Next, we have to find the value of the dividend polynomial at x is equal to half. How do we find the value? Wherever there is x, use 1 by 2. So the whole thing will become numerical because x is the variable. And when you replace x with the number 1 by 2, the entire thing becomes numerical. So you'll be able to, you'll get a number as the answer. And that number is the remainder when p of x is divided by g of x. All right. Okay. So this is the remainder theorem. Now, we'll also see the synthetic division. This will be very useful. Synthetic division is not a part of your syllabus, but it's nice to know of this. Using synthetic division, you can find the quotient and the remainder. Synthetic division is a shortcut of the long division process. Synthetic division is a shortcut of the long division process. Like in the long division process, the traditional long division process, you can find the quotient and remainder, right? Using synthetic division also, you can find the quotient and remainder, but it's a shortcut. In lesser time, you can get it without showing all those steps. Okay. So now you're going to see the synthetic division process. What's g of x? Forgetting. Yes, he was very interested. Tell me. Here, huh? No. For x cube, you should not write. Don't write 4x cubed. It's enough if you write only the numbers, coefficients. Okay, what should you write outside here? 1 by 2 or minus 1 by 2? 1 by 2. Correct. All right. Yeah, children. So while performing synthetic division, see the format, it's like this. Write out the coefficients of every term you see in the dividend. 4x cubed. What's the coefficient of x cubed? 4. Then you must write the coefficient of the x square term, the x term, and then the constant. See, supposing you have 4x to the power 7, and after this you have minus 5x to the power 4 and plus 3, supposing. Now you're performing the synthetic division. X to the power 7, the coefficient is 4. X to the power 6, no. So the coefficient is 0. X to the power 5, no. The coefficient is 0. X to the power 4, the coefficient is minus 5. X to the power 3, the coefficient is 0. So if a particular term is absent, you must write its coefficient as 0. That's important. If a particular term is absent, then you must write its coefficient as 0. Okay, so here we have all the terms. We have the x cube term, and then we have the x square term, and then we have the x term, and then the constant. So we don't have to use 0 anywhere because we have x cube, x square, x, and constant, correct? I'm just telling you, like, if any power of x is missing, then you'll have to use 0 in its place. We'll take up a question later like this, where you don't have all the powers of x. Okay. So now x cubed coefficient is 4, x square coefficient minus 12, x coefficient is 14, and then the constant minus 3. Correct? And here x minus half is equal to 0, x is equal to half. X is equal to half. So 1 by 2. All right. Always start with 0 here. Always write 0 here. Always start with 0. So 4 minus 0 is 4. Now multiply this and write the result here. Multiply this and write the result here. What is half into 4?
2.
What's half into 4? Half into 4?
2.
2. Now what is minus 12 plus 2? Minus 10.
Minus 10.
What's minus 12 plus 2? Minus 10. Now multiply half and minus 10. Minus 5.
Minus 5.
Minus 5. What is 14 minus 5? 9. 9. What is 9 into 1 by 2?
4.5.
4.5. 9 by 2 or 4.5? And what is 4.5 minus 3? 1.5. 1.5. So this is the remainder. This one is a remainder. And this is the quotient. Now, this is the quotient. X to the power 0, x to the power 1, x to the power 2. This is the quotient. That division I erased, but if you can recall, this is the quotient we got. 4x squared minus 10x plus 9. This is the quotient we got there. I'll tell you again. We'll do this whole process again. Oh, it's 9:30. The last number is the remainder, children. The last number is the remainder. The rest of these form the quotient. Now, how do you write the quotient completely? This is the constant. Come from behind. This is the constant. So that is x to the power 0 here. X to the power 0 is 1. So before that it will be x to the power 1. And this will be x to the power 2. All right. So the quotient is 4x squared minus 10x plus 9. And the remainder is 1.5. This is a synthetic division. So see, it's a shortcut. That lengthy division, you have to pick the phone now. Okay, so 4x squared minus 10x plus 9 is the quotient and 1.5 is the remainder. The last number is the remainder. Is that fine? We'll see, we'll take up more situations like this in the next class. And we'll try to understand synthetic division better. All right. All right, children. So that's it for today's session. I'll share all the contents, all that we did in today's class. I'll share the images on WhatsApp. Please complete your classwork by the next class. All right, online children. Thank you so much. That's it for today's session. Any clarification, please stay back. You can ask me. Otherwise, you can leave the call. Good night.
Thank you, ma'am.
Thank you, ma'am.
Thank you, children. Thank you.
Thank you.